Hello guys, my name is Bino, and in this video we'll be focusing on question 4 from the November 12, 2020 N6 mathematics question paper. Question 4.1, we have to determine the particular solution of x multiplied by dy over dx minus 2y is equals to x to the power 4 multiplied by cos x at 2 and 1. So before we can determine the particular solution, we have to make sure that the coefficient of dy over dx is equals to 1 and not x. So we have to divide through by x in order to make sure that the coefficient of the dy over dx is equals to 1. So we divide by x. So what you do on the left, you also do on the right. So that x will cancel out with that x, and our dy over dx minus 2 over x multiplied by 1 will be equals to, so the x to the power 4 divided by that x will be equals to x cubed cos x. So for the standard equation is dy over dx plus p of x multiplied by 1 is equals to q of x. So whatever it is that is after the equal sign will be equals to q of x, and the function before y will be equals to p of x. So p of x is equals to negative 2 over x, and q of x is equals to x cubed multiplied by cos x. And the general solution will be equals to, so before you can get to the general solution, we have to also write the formula for the integration factor, which will be e raised to the power the integral of p of x dx. So the general solution will be defined by y multiplied by the integration factor is equals to the integral of q of x multiplied by the integration factor dx. So we have to determine the integration factor, and after determining the integration factor, we'll multiply it with the y, and on the right hand side we'll find the integral of q of x multiplied by the integration factor. So let's determine our integration factor. So p of x is equals to negative 2 over x, and we can write this negative 2 out of the integral for simplicity's sake, so that inside the integral we'll have 1 over x the dx. So from here we determine the integral of 1 over x, which is equals to ln x, and we know from our logarithmic laws that ln of x squared will be equals to 2 ln x. So in this case we'll be moving from the left going to the right, so this will be equals to, so integration factor will be equals to e raised to the power ln of x raised to the power negative 2, and according to our logarithmic laws, e raised to the power ln of x to the power negative 2 is equals to negative 2 is equals to x raised to the power negative 2. So this will be equals to, so our integration factor will be equals to x raised to the power negative 2. So we will multiply this integration factor with this y. So this is our chief equation, the general solution equation. So now we have successfully determined, so we will take this integration factor and multiply it with the y. So we are done with the left hand side. We have to focus on the right hand side. The integral of q of x multiplied by the integration factor dx. So q of x is defined by x cubed multiplied by cos x, and the integration factor we just determined as x raised to the power negative 2 dx. So let's group the like terms. So x cubed will be multiplied by the x to the power negative 2, and we have our cos x dx. And that will be equals to the integral, so the bases are the same. We add the exponents. So 3 minus 2 will be equals to 1 cos x dx. Now we have to determine the integral of x cos x dx, and we do that by using integration by parts. So the integral of x cos x dx using integration by parts. The formula for integration by parts, we have the integral of f of x g prime of x dx is equals to f of x multiplied by g of x, the product of the original functions, minus the integral of g of x f prime of x dx. So we have to determine which will be equals to f of x and which will be equals to g prime of x between this x and the cos x. So the x is an algebraic function and the cos x is a trigonometric function. So we use the Eilert rule to determine which one will be equals to f of x. According to the Eilert rule, the first one that we come across going to the right will be equals to f of x. As we can see, we have a and t here. So the a on this Eilert rule platform comes before the t. So the a, the algebraic function, will be equals to x, and the t, which is the cos x, will be equals to the g prime of x. So we differentiate the f of x and integrate the g prime of x so that we can get g of x. So the derivative of the x is equals to 1. The integral of cos x is equals to sin x. So now, to determine the integral of x cos x dx, we get f of x multiplied by g of x, or f of x is equals to x, our g of x is equals to sin x, minus the integral of g of x multiplied by f prime of x, or g of x is equals to sin x, and our f prime of x is equals to 1 dx. So x sin x minus the integral of sin x, which is negative cos x plus c. So negative multiplied by that negative will be positive cos x plus c. So the integral of x cos x dx we just determined as x sin x plus cos x plus c, so which is equals to q of x multiplied by the integration factor dx. So q of x multiplied by integration factor dx is equals to x sin x plus cos x plus c. So from here we have y, we already have the y multiplied by the integration factor, which was x raised to the power negative 2, is equals to the integral of q of x multiplied by the integration factor dx, which we just determined as x sin x plus cos x plus c. But you are not determining the general solution, we are determining the particular solution. That's why they gave us the point 2 and 1. So where there is x, we will substitute 2, and where there is y, we will substitute 1. So 1 multiplied by 2 raised to the power negative 2 is equals to 2 sin 2 plus cos 2 plus c. So we have to determine the value of c. So the value of c will be equals to 1 multiplied by 2 raised to the power negative 2 minus 2 sin 2 minus cos 2. So we simply took the 2 sin 2 and the cos 2 to the left, they changed sign to negative, and we flipped the equation. So c will be equals to So to find the value of C, we have to convert our calculators from degrees to radians for the sake of the sine 2 and the cos 2. So C will be equals to 1 multiplied by 2 to the power negative 2 minus 2 sine 2 minus cos 2, and this will be equals to negative 1,524. So by finding this C, we have moved from the general solution to the particular solution. So y multiplied by, we can write that x to the power negative 2 as 1 over x squared is equals to x sin x plus cos x minus, in that place of C, in the place of that C, we substitute negative 1,524. So, or we can just substitute that negative 1,524 there. So we have moved from the general solution to the particular solution, and this will be our answer for question 4.1. And that x to the power negative 2, we can write it as 1 over x squared. Question 4.2, we have to determine the general solution of d squared y over dx squared minus dy over dx minus 2y is equals to e to the power 2x. The complete general solution will consist of the complementary solution plus the general solution yp, yc for the complementary equation. And to determine the general solution, we have to first get the auxiliary equation from this differential equation. So d squared y over dx squared will be represented by r squared, and the dy will be represented by the r. And because this one does not have a d but it has a y, so it will just be negative 2. And because this one does not have a d and it does not have a y, we equate 0 to it. So we have to factorize. So the factors of r squared, it's r and r. The factors of 2, it's only one factor of 2. 2 multiplied by 1, so we have 2 multiplied by 1 as the only factor of 2. So the numbers that we can multiply in order to get 2, it's only 2 and 1. So we take this sign, we put it here. The sign that we put here multiplied by this sign should give us that sign. So positive multiplied by negative is equal to that negative. So we take the bigger number, provided that the coefficient of r squared is equal to 1. So if there was maybe a 2 before r, then we were not going to take the bigger number. We were going to use another method to solve this. But we take this bigger number and we put it here and the smaller number there. So let's test if this is correct. So negative 2 multiplied by r is equal to negative 2r, and r multiplied by the positive 1 will be equal to positive r. Negative 2r plus r is equal to negative r. And so this is correct because we also have negative r as our middle term. So r minus 2 will be equals to 0, or r plus 1 is equals to 0. R will be equals to 2, or r is equals to negative 1. So these are the roots of our auxiliary equation. So we use these roots to determine the general solution. So the formula for the yp, the general solution, is a multiplied by e raised to the power r1 multiplied by x plus b multiplied by e raised to the power r2 multiplied by x. So we choose between r is equals to 2 and r is equals to negative 1, which one will be equals to r1. So let's choose the r is equals to 2 as our r1 and r is equals to negative 1 as our r2. So you can choose this one to be your r1 and that one to be your r2. So the choice is yours. So r1 is equals to 2x is equals to 2 multiplied by the x. R2 is equals to negative 1 multiplied by that x, which will be equals to negative x. So this is our general solution. We have to determine our complementary solution. So we use, so our YC, the complementary solution, we use what's on the right hand side to determine what our complementary solution will be. So it was supposed to be C multiplied by e to the power 2x. So we were supposed to just take that, but because we also have e raised to the power 2x in our general solution, so if this was 3 or any number except for that 2, this was going to be our complementary solution. But because this, the 2x is the same as that 2x from the original equation, so we have to introduce x there. So YC, the complementary equation, will be equals to c multiplied by x multiplied by e raised to the power 2x. So we take this y, we substitute it there. So to determine, so we also have to determine the first derivative. So the first derivative of this, we will substitute it there, and the second derivative of this, we will substitute it there. So let's first start with the first derivative of that. So we have two functions, x, we have two x functions, x and e to the power 2x. So we have to use the product rule to differentiate this. So the derivative of the x multiplied by this whole thing, so the derivative of the x is equals to 1 multiplied by e to the power 2x plus the derivative of the e to the power 2x multiplied by that. So the derivative of e to the power 2x is equals to 2 multiplied by e to the power 2x. So the 2 is the result of derivating the 2x, and we have to multiply it by the cx. So this rearrange will be c e to the power 2x plus 2c x multiplied by e to the power 2x. So we'll take this and we'll substitute it there. So we have to find the second derivative so that we can also substitute it there. So d squared y over dx squared. So the derivative of this, so the derivative of the c raised to the power e2x will be equals to 2 e2x, and again the 2 is as a result of differentiating that exponent to x. So because there is x here and x there, we have to use the product rule to differentiate this. So the derivative of the x will be equals to 1 multiplied by the 2c e raised to the power 2x plus the derivative of the e to the power 2x will be 2 e raised to the power 2x multiplied by 2c x. So we rearrange this. So we start with the 2 and the c and the e to the power 2x plus 1 multiplied by 2 will be equals to 2c e raised to the power 2x, and we move to there. So 2 multiplied by 2 will be 4, and the c and the x e to the power 2x. As we can see, these ones are the same, so we can just add these two. This 2 plus that 2, will be equals to 4 c raised to the power e raised to the power 2x plus 4c x e raised to the power 2x. So we take this d squared y and we substitute it there, and this dy over dx we substitute it here, and this y we substitute it here, so that we can find the value of this c. So we have d squared y over dx squared minus dy over dx minus 2y is equals to e raised to the power 2x. So we substitute the d squared over dx squared, which is this there. So we have 4 c e raised to the power 2x plus 4cx multiplied by e raised to the power 2x minus the dy over dx. So in the place of this dy over dx, we will substitute c e raised to the power 2x plus 2cx e raised to the power 2x, because this is equals to that, minus 2, and in the place of this y we substitute that the cx e raised to the power 2x, and we equate this to the e to the power 2x. So from here we have to solve for the c. We are solving for the c. So we distribute this negative inside the parentheses. That negative multiplied by that positive will be negative, and this negative multiplied by that positive will be negative 2cx e raised to the power 2x minus 2cx e raised to the power 2x is equals to e to the power 2x. So we group the like terms, so we can see that this 4c and that they are like terms. The 4c e raised to the power 2x is a like term with the negative c e raised to the power 2x, and this 4cx e raised to the power 2x is like term with this and that, the minus 2cx e raised to the power 2x, and this other minus 2cx e raised to the power 2x is equals to e to the power 2x. So we can, the 4c e raised to the power 2x minus this c e raised to the power 2x will be 3 c e raised to the power 2x, and this negative 2c x e raised to the power 2x, and this negative 2c x e raised to the power 2x will be minus 4, and they will minus with this one. So these ones will cancel out each other, and we'll be left with e to the power 2x on the right hand side. So the e to the power 2x, so we divide throughout by the e to the power 2x, and that e to the power 2x will cancel out with that, and that will also cancel with that. So 3c is equals to 1. So our c will be equals to 1 over 3. So the full solution will be equals to 1 complementary solution by plus the general solution yp. So the complementary solution is equals to cx e raised to the power 2x, and the general solution is equals to a e raised to the power 2x plus b e raised to the power negative x. But we have to substitute, so we determine that c is equals to 1 over 3. So in the place of that 3, we substitute the 1 over 3. So because we are not given any points, we are told to determine the general solution, so there won't be any need for us to determine the value of a and b. So this will be our general solution for question 4.2. Please subscribe, like, and share this video with your fellow classmates.